Hey there, ladies and gentlemen. Welcome to lesson 8.2. This lesson's all about adding and subtracting polynomials. Now, obviously, before we can do a whole lot of talking about adding or subtracting polynomials, we probably need to know what a polynomial is. So a polynomial means many monomials or a sum of monomials. So a monomial, as we learned in previous lessons, was our ability to have something that's a number, a variable, or a product of numbers and variables. So a binomial has two monomials. It's the sum of them, or it could be the difference if we subtract the two pieces. So if we had like 8x to the second power plus 3, there are two chunks here that are monomials. I've underlined them. So this is what's called a binomial. A trinomial has three chunks. Each chunk is separated by a addition or subtraction sign. And I'm going to do, here we have another one. This is our trinomial because there are three pieces. And the degree of a monomial, each individual chunk, each term of our monomial or polynomials has a degree. And the degree is determined on what the exponent is. So if we had a monomial of x to the fifth, y to the fourth for our monomial, that has a degree of 9 because 5 plus 4 makes a degree of 9. So over here, this trinomial has a degree, or this individual monomial piece has a degree of 2. This one has that imaginary 1 there that we don't have to write because the exponent is a 1. The degree of a polynomial is the greatest degree for any one of the terms. So if you look at my trinomial here, there's a 2, a 1, and a 0 for their degrees. So the whole polynomial has a degree of 2 because that's the largest degree of each of the individual terms. Standard form means that we're going to write our polynomials in degree order from greatest to least, which means you're going to make sure that you have the largest exponent values first and then the smallest or constants last. Now, the last words here we have is the leading coefficient. It's the coefficient of the first term. And that could be like a -1 or even a 1 if the first in standard form is just like an x or an x to the 19th power, or meaning that there's no coefficient. Now, these are the names of the polynomial's degrees. So if I had a degree of 1, it's called linear. A degree of 2 is quadratic, cubic, quartic, quintic, sixth. These are the names of those things. So as soon as we get to like having a 6th degree polynomial, we're just going to say 6th instead of having like a fancy word for it. It's not going to be a hextic or a heptic or an octic. We're not going to use those words. We're just going to keep with the numbers there. All right, so here's how we actually do the math. When you add polynomials, it's important that you align the terms and then you add. So I have this first polynomial. It's already in standard form, so I'm just going to rewrite it because I'm happy with how it's written in standard form. And then I'm going to change the order using the commutative property of our second one because that one's not in standard form. So we're going to put them in order and we're going to put them beneath the like term. So I have my 5y to the second power was beneath the 7y to the second power. My next one is this -4y, and I need to put the sign that goes with it in front. I would need to carry that over. And then there's that +2, so it's a +2 at the end. We are adding these two things together, so just like we did in chapter 6 when we had our systems of equations, we just add the coefficients, the numbers in front. So this becomes a 12y to the second. This one is a -2y. And over here we have a -1. So this is just a simple addition of the coefficients for each individual term. So the same process will happen on example 2. I would encourage you to try this one on your own. Hit pause, try it on your own before I do it, and then see if you get the same answer as me. So I'm going to do the same thing as last time. So I wrote down the first problem. Now I'm going to rewrite lining up my terms. So I have a -7x. I'm going to write underneath the 4x to the second power. Then we have our +3x. We'll have a +3x, and then this -9. And since we're adding this whole polynomials together, we just add the coefficients. So this 4 and a negative 7 makes a negative 3x to the second power. I forgot to put a 2 here. And then a negative 2 and a positive 3 makes a positive 1x. I don't need to write the 1. 7 and a negative 9 makes a negative 2. So my leading coefficient is a negative 3. The degree of this polynomial is a 2, and it's written in standard form. Now when we subtract, that's kind of like what we talked about as 7th graders, that you're going to do that keep, change, change. The actual math term is to using the additive inverse or adding the opposite. So the same idea is going to take place. You're going to want to put your numbers into a standard form and make sure that you have lined up your like terms. So I have a 8y to the 4th will be my first one because that's got the largest exponent. Then we have a positive 6y to the second and a negative 5y. My next ones, I'm going to do the exact same thing. I'm going to put my largest ones first, 9y to the 4th, a positive 2y to the second, and a negative 7y. We are subtracting. So I'm going to now change the sign of every single one of these problems so that we have subtraction turning into adding of the opposite. So we keep, change subtraction to addition, and change all of our signs. And now we can do what we did on the previous example. Just add them like we normally would. An 8 and a negative 9 makes a negative 1y to the 4th power. A 6 and a negative 2 makes a positive 4y to the second power. A negative 5 and a positive 7 makes a positive 2y. Now you can imagine that we could make this a lot harder, and we'll show you that stuff when you return. Let's try another one on our own, and then we'll give you one to do when you are not listening to me yap about it. So in 11n to the 3rd power plus 6n to the second in standard form plus 2n. And I'm going to rewrite the other one. 5n, oopsies, I almost screwed this up. 5n to the second should go underneath the n's to the second. So I have 5n to the second plus a 4n and a minus 3. Now you'll notice that we have open spaces. Open spaces are just the numbers 0. So when we subtract stuff, we're going to actually be adding the opposite. So we're changing the signs of all of these things. And now I can add together. So an 11n to the 3rd plus nothing makes 11n to the 3rd. 6n to the second and a negative 5n makes a positive 1n to the second. 2n and a negative 4n makes a negative 2n, and a 0 and a 3 makes a positive 3. Now this is a polynomial. It's got 4 terms to it. The leading coefficient is 11. The degree of this polynomial is this 3. This is the example that we're going to do tomorrow when you get to class. So check it out, read it, maybe hit pause, see if you can get done before me. And the last one is we're going to try to write an equation to represent the sales of the video games and what were those sales in 2009. All right, so you check that out, and we will show you how to do all that stuff tomorrow when you return and be like a warm-up to this type of math. All right, folks, this is the Burma Nation. This is take 2. The first take, I got a random restart, so my voice is kind of raspy. Maybe I'll get some water. All right, Burma Nation signing off. We won't waste any more of your time. Have a great day, folks.